Hello, welcome. We're going to go ahead and get started on our demonstration video for this module. And what we're going to do is we're going to actually focus on module or chapter 6, excuse me. And I wanted to actually go through and do some of this golf scores assignment that you have. Now I'm going to leave it up to you guys to complete the right portion, because you're going to be writing two programs, one to write the golf score, and then you're going to be writing some code that is used to read the golf score, and then displays those scores. We may take it a little bit further, and actually we probably will take it a little bit further for outputting probably the average of scores, something like that. So let's go ahead and get into it. Now first we're going to begin with properly putting our code base inside of a folder. And if you're using Visual Studio to create your files, Visual Studio Code or an editor, that's okay, but it's not okay not to understand how folders and files work within a project. And that's part of one of the things that we're going to unfold a bit today. So what I'm going to do is I'm just going to go on the desktop and I'm going to create a folder, and I'm going to call this CH6 Golf. And that's going to be the folder that holds my files that I'm going to use for this particular challenge. So what I'm going to do then is I'm going to actually create two files. One is going to be the text file that's going to be golf scores. I'm going to call it golfscores.txt. Now you're going to be writing the code that actually creates this file. I'm going to be typing mine in and putting the scores in directly. So the next one that we're going to need is we're going to need an actual Py file that is our program for our interpreter golf, and I'll just call that golfscores.py for py .py. And then I'm going to go ahead and open that, and you know what? I have now got this going. Okay. So I'm going to go ahead and just open the file directly from the folder, and this is why it's nice that you put it on your desktop so I can find it. Let's see, I called it Golf Scores, Chapter 6 Golf Scores. So if we're doing it by name, it'll be Chapter 6 Golf. There we go. Okay, so this is going to be golfscores.py. And you know what? Let's go ahead and do, let's open the text file inside of here too. And I just created a new one. Let's say open file, and let's do golfscores.txt, because I'm going to be typing the information in, so we don't need to use Notepad as an editor. Visual Studio Code is a text file editor. And now we have golfscores.py. Let's go ahead and look at the challenge again and get a real understanding of what we need to do from your book. Let's see here. We have programming exercises. You may have a different version, that's fine. You may have a different version of your book, that's fine. Especially if I've made some updates. So if you don't have this particular version, or an earlier version, a newer version, or an older version, that will be okay. That's one of the reasons why I specifically put the assignment in the module. So what we have here is we should actually have, for chapter 6 and our programming assignments, the golf scores assignment. So we want to write two programs, a program that gets the player's name and a golf score, and then saves those records. So then we got to decide, well, hey, how are we going to delimitate this information? And what we can decide is, hey, what should go first in the file? Should it be the name? And if we're dealing with a player's name, should we do first name and last name? And I'm going to say no. Let's just do one name, a handle. Let's not do, it's just going to complicate it a little bit more, and I didn't want to get into the weeds too much, but it does say the player's name. So you know what? Let's go ahead and do first name and last name. That would be probably better. Let's go the hard road instead of the easy road. And so basically it outputs, you're going to output the golf scores and then you're going to read them. I'm going to add a qualifier to this. We're going to add the average up. So you're going to actually do that. I'm going to add that to the assignment where we're going to have an average of golf scores output. So we're going to do part of that today. I'm going to leave some of it probably for you guys to finish. We'll see how that goes. But what I'm going to start with actually, and let's actually go back to that, is I'm going to start with one of your programs from your book. And that's what you should be using mostly for your reference. Use your book. It's got a lot there. And they actually have a program in there called Display File 2. And you know what? It's in there. Let's see. Display File 2. We will do a search for it. Let's go with just display file. Okay, well, that has been a miserable failure. Okay, we got read file. We've got all kinds of different code in here that we can use as a reference point to begin writing our own code. And one of the ones that I really liked was, because we need to discuss exception handling, was the display file 2 code. And that's actually in section 6.4. So I went over here to the exceptions section of your chapter, and the display file 2, or the display file, here it is, display file. So this is a good beginning, but we're going to actually demo a little bit more on this one, because I expect you guys to have your try excepts surrounding your input from a user, so that if you're expecting a specific input, that it throws an error for you. And more on that throwing an error here shortly. But this is our beginning, and we're going to start with our main function. And I'm now in my golf scores, and this is another expectation I have, that you always have a main function. We should not be writing code just willy-nilly out in the middle of nowhere in your Pi document. Have a starting point. And whenever you reference or use the main function, you define the function always above where you use it, guys. That's top-down programming appropriately. So you should always be defining a function above where you actually call and use it. So this would be the function definition. Now, what this does is just defines a main, that this program actually has a main, and then it calls it. So this defines that we have a main, this calls it, this is the actual main function. So this is the definition of main that we are going to create. Notice the definition is above where we call and use the function. That's top-down programming. That's the way you should always do it. So what we're going to do is we're going to start with a file name. And we're going to input that. You know what? No, we're going to hard code that. We're going to say file name is equal to golf scores.txt. Now if I look at my folder and verify that golf scores.txt is there, now let's delete it because I'm going to demonstrate the try and accept working for us. Okay, so what we want to do is we want to open up this file that doesn't exist in our folder. And this will help you kind of get your files in the right place, because if your program can't find it, it's going to tell you it can't find it. And therefore you don't have any kind of like, oh, what's going on? Oh, I put the file in the wrong folder or something like that. So now what we'll do is we're going to use a try block. Now a try block, all it does is contain code in its scope. So anything that you tab into this try block is going to be tried. And then if anything between that try block and your exception catch, which is, and we're going to be catching primarily an input-output error when we're trying to open up a file. If there's an error that happens, like specifically with the open function, when we try to open a non-existing file for reading, it's going to throw the error and modify the flow of our program. And then we can output an error message that we were unable to find that particular file. So if an exception happens, then we are going to output that, hey, we cannot find this file. And that exception only happens when you try to open the file that doesn't exist. So we're going to say the in file that we're using, this is our file object or file pointer here. So my file pointer is called in file. And we're going to say open file name for reading. Okay, so what should happen then, and let's just, for fun, let's just do a print here, hello world. Now I'm doing that specifically so I can show you what happens when the try does not find the file that we have in there. And you notice here that I'm not doing any kind of weird things like C:\\\, or I'm putting an R in front of here and doing C:\\, my folder, whatever, any of that stuff. That's not the way you do things. You open a file implicitly unless you have a graphical user interface or you're using default arguments for your main that tells your application where to find the file that needs to be opened. So now let's go ahead and just test this, and I'm going to put this in the debugger so that we can just see what's happening. And actually what ends up happening first is not here. None of this happens first. What actually happens first is this function is called, and since it's defined above it, it knows what main is. Therefore, it can then call it, and your runtime goes into here. So I'm going to go ahead and set my breakpoint here so that we can debug this. And I'm going to go here to run, start debugging. And it looks like I got to install an extension for Python for some reason. I may have okay, this one's good. It looks like my Python, interesting. Well, this is kind of okay. I may have some issues that I need to deal with, and we may need to come back to this. Nope, there we go, Python file. We're good. I just had to choose the one that I already had installed. Okay, so the program's, the interpreter has started. I choose the interpreter that I had installed. And I'm in debug mode, and you notice that the process stopped here. Now over here we've got some locals. These are variables that have been created for us. Mostly you would use a step over here when you're debugging, but I'm going to do what's called a step into so that I can step into this function call and see what's going on. So I'm going to do a step into, and now is when I go into a step over. Mostly, again, what you'll do is step over unless you want to examine the code that's going on behind the scenes. Like the open function, I don't want to examine that, so I'm not going to do a step into here because I don't need to look at that code. I'm just using it. So I'm going to do a step over. Okay, no problems. We're in our try block. Now is when I first try to read the file name golfscores.txt. Now, if you look in the folder, it's not there. It's gone. So now I'm going to do a step over. But here's what's going to happen is inside of this open function, there's an error checker to see if that file exists. If it doesn't exist, it throws the error. And here's what it happens when it throws the error. It actually changes the flow of your program. It goes down then to the exception handler, and it will skip over and not do line 8. It won't do it because the exception handler is designed to change the flow of your program so that it doesn't totally crash your program, so that you can recover from the error. And so what you're going to see is it's going to, when I do a step over, it's going to go down in flow. It's going to skip over. No print hello world is going to happen. That's going to skip over and go down here to the exception and print out these errors. So I'm going to do a step over. Boom. Now notice down here in the terminal, there is no hello world being printed. So line 8 never happened. Okay, now I'm going to go ahead and we've got an error. All right, so let's run this again. Instead of doing a step into, let's just move my breakpoint and put it up here now. So I don't have to do a step into, I can just do step over when main is called. And then let's go over here and let's put in the new file, golfscores.txt, and let's specifically, this is a nice little trick that I use that a lot of new students will have a problem with. Let's highlight that, copy it. Let's copy what we named it over here, and let's paste it here so that we know that we haven't made any mistyping, because that will get you confused, and I swear you will waste 2 hours and notice that you've inverted an E with an S or something. And that's a very common issue that people have. Okay, so we now have the file that is there. So this try should not be catching an error within the open function. So now we're going to run it. I'm going to do a step over. Okay, so now we're going to try to open the file. Oh, it worked. No error was thrown. It did not mess up with our flow. We can begin and go as normal. This code now will never be reached because the try was successful. And that's how try and catches work. They actually modify the way your program flows to skip over code that would crash your program or your script. So hello world is printed and we were successful. Now guys, one thing, if you're having a problem figuring out where you should put your file, it goes in the same folder as your Pi file, but sometimes students get confused, and because they work too much in the editor instead of the folders, and they will have their Pi file in a whole nother folder than where they put their text file. So if you are absolutely to that confusing state, sometimes it's better to just write the code to write the file first, and then you will know where it goes because you had the program create the file. And when you have the program create the file, you'll tell it just, you won't put in like C:\\/ or anything. You'll just give it a name. Okay. So now we're going to move on to the next bit, which is actually getting some data and displaying them. So I'm going to go back here. I'm going to go ahead and reopen that file because I recreated it. Okay, here's golf scores. I'm going to go ahead and say that we're going to have a first name, a last name. And guys, it's been so long since I've been golfing, so I have no idea what golf scores should look like. I'm just going to throw some numbers in here. I'm sure a few of you might be laughing about that, but let's do this. John Doe, 67. Now here's what I'm looking at. When I'm typing this in, I'm using some natural delimiter. I'm using the space as a delimiter, and then when I hit the enter key, I'm using the new line character implicitly as a delimiter. Okay, so Jack, let's go Darcy Jones, Jones, and let's say Darcy's a star. Okay. Now, because the new line is a delimiter here, I'm going to go ahead and for the last entry, I'm going to hit enter. And then I'm going to save the file. Okay, so the first goal that I'm going to have is just reading a line from the file. Then I'm going to want to tokenize and parse it. Because we're going to add the average. We're going to output the average of all scores. For everybody. And I always go with the rule of get your memory, print your memory. So what we want is we want three variables here. We want first name, just assign it to nothing for now, last name, and over and over through our loop that's going to read this file, we are going to print the first name, the last name, and the score. And the score is going to be equal to 0. And then what we're going to do is we're going to do the average. Now this we're going to assign to 0.0 because it's going to be a floating point number. Okay, so now I'm going to go ahead and save this. And we are going to go to another example. And the other example is going to be, because the example I was referring to, the display file, the second display file example, it reads the whole file at once. We could do that, that's fine. But what I want to actually do is I want to read one line at a time and then parse and tokenize each line. Because within each line, we have a space that is separating out these values. So we're going to use probably the split function on that to get these all separated so that we can print them out and then count them up. And for that, I'm going to go and get an example as well from your book, as well as take a little mini break, and we'll be coming back to that portion here shortly. I'll see you guys in a little bit. All right, hello, welcome back. We are going to continue on with our program that we were writing. Now, as far as an example from your book, I found two of them, your readcells.py program, and this one also, the readcells2.py, are adequate to work with. I prefer this one, this one right here. So we're going to actually use this bit of code to begin with, and basically this while loop, what it does is it continues to read from the file until the file pointer gets to the end of the file. And remember, your file pointer is this guy right here, in file. So every time you do a read with this in file, it moves that file pointer and advances it in the file and until it gets to the end of the file. So what we're going to be doing is we're going to be using a read line for our file. So we'll do the file pointer will begin here at the beginning. We'll do a read line, and the file pointer will be right here. Then we'll do another read line, and the file pointer will be right here. Then we'll do the last read line, and the file pointer is there where there's nothing, and therefore the while loop will trip as true because we're giving it this while statement that essentially says keep going until you've got nothing, till you get nothing from the file. And what we're going to be doing with line is using it, and all it is a string. So let's actually go up here and declare it. Line equals to a string. And you notice me, I'm using the double quotes here and the single quotes. In Python, it's the one actually means character, the other means string, but we can use them interchangeably in Python. Okay, now within my while scope, I'm going to start reading this line, and the only thing that I care about, and please do not write a whole bunch of lines of code and expect them to work, guys. Really, you only want to write 2 or 3 and then test and debug. Write another 2 or 3, test, debug. Do not write any more than 2 or 3 lines of code and expect it to work. That's part of your journey. So what we're going to do here is we're going to say line is equal to, and this is where we get into the file pointer, in file dot read, but we're going to use read line. So we're going to get a whole read line at a time. And then all I want to do is print it. That's all I care about. This is my 3 lines of code that I want to test. I'm going to set a breakpoint right here so that I can look at it and see what's going on. I want to make sure I've saved this. Okay, go over here. Control S also saves. And then now I'm going to go ahead and go to run, start debugging. And it's going to stop here. And I can see over here in file, I can see that in file actually is something in my locals. This is for the scope that I'm in. And so in file, we've opened the file successfully, basically because it has something in it. Line is equal to nothing at the time. And then we go and do a step over. And what happened? Oh, something died. Why? Well, because line has already been declared as nothing. So the way that we may want to do this is not to declare it at all, allow it to be defined in the while loop. Okay, now we step over and we have an error. Cannot access local, oh, because it's, you know what? Let's go back to our example and see what's going on. Something is not right here. How did they use line? Right there. That's why I don't like using the while for this, because you often have to, before you can invoke the while, you have to do your first read line. So let's do this then. We can modify this so that we declare line here and ask it to read the first line. Then it'll drop down into the loop. So I'm going to use infile.readline here. And let's do this. I want to zoom in for you guys, so I'm going to do a quick journey over here. Visual Studio Code. Zoom in. Zoom in, Control plus. Control plus. Let's try that. Control plus. There we go. Okay, so I just want to help you guys out a little bit with that little side journey. I'm going to go back a little bit. There we go. That's probably better. So we actually need to, and we can bring this back because this is a little bit better programming. And in fact, yeah, that's fine. Let's read the first line in the file, which means now we got to print that line after we've read it. So this is the problem with using the while loop, is you actually have to read the first line, then process, read the next line, and process. So you're actually kind of duplicating your code. And I don't really like that. Okay, so it looks like we're outputting stuff, and we go down to here. It looks like, yeah, okay, so it outputted the information. And it looks like it kept the new lines in there as well. So we're going to have to probably strip some of those out. Let's actually look at that in the debugger and see what's happening. Let's look at line after the first read. Yeah, see right there, \n. So it read in the first one here with the \n. You know what? I'm going to do a total reverse on this. I just don't like the fact that we're doing two things in two separate spots. It's kind of redundant and ridiculous. So let's go back to that other example that uses the for loop. I like this. For every line for every line in the cells or in the file pointer. So the for statement is doing the read line for us. So that for statement is actually doing the read line for us, and it's doing a lot of work there. I kind of don't like that either, but you know, let's look at it. For line, let's put our in file here. And then we're going to print line. So it looks like it's doing a lot of steps for us. Instead of all these 4 lines of code, it's saying, hey, for every line in the file pointer, that means it's actually doing this step for us every time through the loop. That's kind of confusing too, but it's going to work just as well. So without the, so we got our first line. Again, it's got our \n in there. We got our second line. We get our third line. And we can see it over here in the output or in the locals for the debugger. You know what? I don't like that either. Let's go back to the redundant one because there's just too much magic there. And the whole goal of this is for you guys to really get a conceptual understanding of what's going on. And even if we have to be more verbose with it, I'm fine with that. Let's just go ahead and do it like this. And let's move on. There's just a little too much magic there for my... And that's why... Okay, guys, that's why Python is so popular, is because of the magic. However, too much magic shows me that people don't really know what they're doing. And I'm interested in assessing you on what you're able to actually know and do. So be as verbose as possible where you can. And if it comes from your book, it's safe. But if it's something that you got from the web, you may have to redo your assignment. And that's not a bad thing, guys. It's not a bad thing to have to redo your assignment for more clarity and understanding. So don't get discouraged with that. Okay, so let's go ahead and do it this way. That means we got to process it here and we got to process it there. But we've done the first thing. We've gotten our memory. We can print our memory. Let's go ahead and do one more run through here. Looking at our locals over here in our debug window. We get our first line. Boom, we got a \n. We're going to have to get rid of that \n. We get a second line. Boom, we got a \n. We're going to have to get rid of that \n. So let's do that first. And what we can do here is we can do a line is equal to, I believe it's going to be strip, And strip runs by default. I think strip reads by default with a space, but if you put in the character you want to strip, it should strip out that character as your argument. So let's see if that actually works. Okay, let's read the line. Oh yeah, it stripped it. It stripped it out. You can see over here when I stepped over. Okay, so again, let's look at that again. We read the line. We see it over here. It's got the \n. Then we strip it. The \n is good. Gone. So now we're ready to process it. So let's go ahead and duplicate that over here. Line is equal to, you know what we could do? Is we could actually do a dot strip here. So basically we can say, hey, take what is being assigned to line and strip \n from it, and that'll work. That'll work very fine. But again, we're getting to too much magic, so let's break it down into 2 steps. Line, and we can just copy this one down here. And let's go ahead and run this without the debug breakpoint. And we'll see that nice and neat, without any extra \n's in there, we have some cleaned up output. We still have one more step to take. And that is we need to separate these guys out. And to do that, what we need to do is a split function. Now that one I did a quick reference because, you know, I work with a lot of different languages, and sometimes I have some, you know, need for a reference. So I just typed in real quick Python split, and this is how the split is used. Now, if I remember right, split works on the default of a space. So, but you can send it a specific character to delimitate based on. And you see the examples here. So since we are actually splitting on a space, we're not going to have to send it an argument at all. It'll just work naturally with that in our code. So we can just run the split function. But what does it then do? What does it then return? Well, let's go back. What do we do with it? Well, it's going to return I think it should be a list. Yeah, it'll be a list of items that represent each character. So we can actually print that. So let's do this in this manner. We're going to say str string list. You know what? Let's do this in scope. We're going to say string list equals line dot split. Okay, now again, we don't need to send it anything. And then we're going to do a print of str list. Okay, and let's actually set a breakpoint here. Okay, we strip it out. We got line over here. Then we tell it to split based on the spaces. Okay, then we split it, and look at this, string list. You see how it's split it up into different values? Now we can use what is called, and you're going to be learning about lists here shortly in the upcoming chapter. You don't have to use a list to solve this challenge, though. You can do this where in different manners, but you're going to be learning more about them coming up. What we're going to use is a subscript, and we're going to use a location value to grab out a specific item in this list. So this will be position 0, position 1, position 2. And since we want to average up position 2, the number 34, that's the one that we're most likely interested in the most. But we know this works. So what we're going to do here is let's just go ahead and print the list. let's copy this, print the list, okay? But here's where I'm going to kind of turn you loose a little bit. What I want to print is just something, just one value in the list. And let's do this. I want to set the score. You know what? Let's make this a floating point value because we're going to be using a division on this. And I'm going to want to set the score equal to the list's item at location 2. Okay, now let's test this. Let's look at what it actually gives me for the score. I gotta hit stop here before okay, so I'm gonna run this. All right, now I'm gonna step over. It prints the list. Now I'm gonna go to position 2. So remember, this is 0, this is 1, this is 2. And guys, in programming and mathematics, you cannot forget 0. 0 is actually the first one. It's 1. So in programming and development, 0 is actually 1. Even in mathematics, a lot of mathematicians will say that 0 is always implied in formulas, etc. But when you're actually applying those formulas, 0 is actually 1, and 1 is 2, and 2 is 3. So 0 is always the first one. Okay, so let's see what we get for score here. Let's look over here at score. 34, great. Oh, but it's 34 as a string. That's not great. And I use these double quotes and single quotes interchangeably, guys. They're both strings. Here's what we need to do is we need to convert this score to a floating point value so that it removes those double quotes, because if we want to process and add this score up with the average, so we're going to say that average equals score here to begin our addition. And so I should have average changing to a number so that I can process it. That's the whole point here in that conversion. Because remember, when you go to the user, you convert your numbers to strings. When you come from the user, you convert your numbers or your strings that the user enters back to numbers. And guys, that works with console operated black screens, terminals, and it's the very same when you get to graphical user interfaces. It does not change. To the user from numbers to strings, from the user from strings to numbers. Okay, so we're right here, we're coming from the user. In this place, in this example, the user is a text file. Okay, so score. Oh, let's back that up because we didn't see the conversion. Okay, let's go ahead and look at the conversion again. Okay, the program stops here. I print the list. Now notice that score is 0.0. I take the string value inside of the list at position 2. I convert it to a float and then assign it to the score. Now if you look, you see how that 34 has quotes around it? That means it's a string, guys. It's not a number. Step over. Boom. Score 34.0. Notice there's no single quotes around it at all. No double quotes, single quotes, any quotes whatsoever. It's not a string. It's an actual number. Now we can add to it, subtract from it, divide from it. We can put it on the CPU for processing. When you process a string, you're just concatenating it. There's no actual addition or subtraction. You just add the strings together and make one longer string. But strings, you have to, if it's a numerical value in a string, it has to be converted to an actual numerical value that you can put on the CPU to process with another numerical value that's the same data type, such as, an int can add to an int, a float can add to a float. An int cannot add to a float until a conversion happens. An int cannot add to a string until a conversion happens. So this code is going to be duplicated down here. Okay, and then what we're going to do is we're going to do this. We're going to say print average. Then right here, before we print average, we're going to say average is equal to the previous value of average plus the new value of average. So we're saying the new value of average is equal to the old value of average. Oh, that doesn't work, because we just did average here is changed. You know what? We need another variable. We need a temp average, because we need to have a running total average, and we need a temp average. So this needs to be T average equals 0.0. Okay, so once I get the average, I can say T average. And here, since we're just starting, I could just assign it to average. But here, down here, I'm keeping a running total. So I'm going to say the new total average is equal to the old total average plus the average from the new score. All right, that's going to total it all up. Okay, print the list. Boom, boom, boom. Okay, so total average is going to have the first score. Then we go into reading okay, we get the new score. Which shouldn't have been 34. It should have been 67. Oh, I made an error, didn't I? Look at what I forgot. Wait. Something didn't happen here. Oh. Yeah. I didn't split it. That's why. Whoops. Uh-oh. That's why my score did not work correctly. No, yeah, I didn't split it. So it wasn't changing the value for my list, my list string. Okay. Here we go. Ready? Get the first score. Boom, 34. Start the average. Boom, print the average. Okay, so we print the first record with the average. While I'm reading the file, read the next line, strip the \n. Boom. And then the next thing that I do, let's create a new list from the new John Doe record. Split the list. Now I have value 67 I need to get out of the list. Get the value out of 67 and score. Then let's calculate the new average based on the old average with the new total average based on the old total average with the new average. Even I am doing. Oh, and we're up to 101. Okay, great. So let's take this out and look at the whole thing running without debugging. Okay, so we've got a problem here. It says list index out of range. So what ended up happening here is we tried to split an empty. Essentially what happened is when I got to the end of the list, it died. So what I want to do is I need to actually set a breakpoint here and see kind of what's going on and detect when this error happens. So we read our first thing. Good. Let's bring our windows down here so I can actually see things. Oh, let's bring that down. There we go. We got our first record. No, we got our second record. John Doe, Darcy Jones is our next one. What do we got in here? Darcy Jones is our last one. We got our first record up here. We got our second record. Now we're currently getting our third record. Okay, we split the list. Good. Good. Okay, boom. Okay, now is line is 0. So I think I'm missing something that we should have done, but didn't. And I know what it is. We did a typical error here. We're starting this code with a read line when we should actually be ending this with the read line, because it's doing things backwards. So we should be processing our first line that we read, so we don't need any of this. We read the line first, then we process, and the last thing we do is read our next line. That way the while loop works properly, because essentially, and this is a good example of how things can go wrong. Essentially, what is happening is when we go back to the last while loop, line has still got something in it. We never have a chance to read nothing in the record. So we get to our last one, we read this line, we process it, but we do not do another read line to get nothing. So that's why the read line has to be at the end. So we read a line, process it. Read another line, process it. Read the last line, process it. Read an empty line, come out of the loop. This is a very good example of how things can go wrong with your logic and your program flow. Okay, now if you're wondering if I did that on purpose or by accident, guess what, guys? I did it by accident. It's very typical. But this is how you want to code, because it was very easy for me to understand that because of the way I was doing it piece by piece instead of one whole, and I was using the debugger. Other than that, you would be like, well, what's wrong? You wouldn't understand that. So, you know, programming is difficult. It just is. Because you're only fighting against one person, that's yourself. Okay, so let's now read this and test this out again, see if this is working good. Okay, we process the first line. Uh-oh. What happened there? str list. Oh, that's because we created it up above and we tried to print it. So we're doing things a little bit backwards. Let's do this. We need to put this up above. Oh, thank you, debugger. You're saving my life. Okay, so yeah, we can't print the list until we assign the list from the line that we've read. And that line is the first line that we read. And then when the loop takes over, each previous line is then processed. Okay, let's try this again. Okay, strip the line, split the line, get the score. Boom, done. Assign average to the score. Total average is assigned based on the previous total average. Then we read the next line. And then we say, oh, we've got information in here now. We're good. So let's process that new line. Print it. Add it to the average score. Boom. Process the next line. Darcy Jones, which is the last line. Process it. Add it to the total average. Now here's where we should break out, because this is the last record. When we read a line, line is now nothing. Look at that, guys. The while loop comes out and we're done. Woo-hoo-hoo! Finally. Thank you, debugger. Here's your job. Calculate the total average by dividing by the number of records. So what you're going to have to do is you're going to have to create a record variable, and what you're going to do is when you do a read line, that record value, since we know if we get to a read line, let's actually put it down here, and let's not create that. Let's say that we have one record, and every time we do a read line, we need to add to that record value so that we can use it to divide the, I think I spelled dividing wrong. Calculate the total average by dividing by the number of records. So guys, guess what? That's not going to be done here. That's going to be done outside the loop. You've got to actually do that. But you do need to add 1 to the record here inside the loop. That I'm going to leave up to you. Now again, I was a little detailed in this example because you have not talked about lists yet, which is fine. It's a good precursor to it, and it'll get you prepared to think about those as we work our way forward in our chapters. All right, guys, so let's give you one last view of this. Define our main. Define an area for calling our main function. Call the function after the definition. So guys, you should always be creating your functions, defining them above where you call them. That's proper top-down programming. All right, finish that stuff up and turn it in, and have a good one, guys. We'll see you next time. Bye-bye.